pretty exciting news coming out of the astronomy world.
Yeah.
Yeah. And specifically...
about the James Webb Space Telescope.
Right, exactly. It's the James Webb Space Telescope, or JWST, as we like to call it.
JWST. Yeah.
And it's, continuing to deliver these absolutely stunning images and groundbreaking scientific discoveries.
Yeah. It's amazing how often, we're getting these big news drops from JWST.
Right. It seems like every other week there's something new and incredible.
Yeah, yeah.
And this time it's about planets.
Exoplanets, to be specific.
Yes, exoplanets, those planets that are orbiting stars other than our own sun.
And not just any exoplanets.
Right. We're talking about young, giant exoplanets.
Like truly colossal planets.
Yeah, some of them are many times the size of Jupiter.
Really puts things in perspective, doesn't it?
It does, it does.
So what's the big news here? What's got everybody so excited about these giant exoplanets?
Well, the big news is that Webb has been able to directly image these planets.
Directly image them. Wow.
Yes, which is no easy feat.
No, I imagine it's not.
Because exoplanets are, they're incredibly faint compared to the stars they orbit.
Right, right. It's like, what was the analogy I saw? Like trying to spot a firefly next to a spotlight?
Exactly. It's a huge difference in brightness.
So how do they even manage to do it?
Well, this is where Webb's incredible technology comes in.
Okay.
It's got this instrument called NIRCam, the near-infrared camera.
All right, so it's specifically designed for this kind of deep space observation, right?
Precisely. NIRCam is designed to see an infrared light, which is the kind of light these young, hot planets emit most strongly.
Okay.
And it also has this special feature called a coronagraph.
A what?
A coronagraph. There's basically a mask, you can think of it that way, that blocks out the light from the star. So it's kind of like, putting your hand up to block the sun so you can see something fainter.
Ah, that makes sense. So they're essentially blocking out the starlight to reveal these much fainter planets.
Exactly. It's an incredibly clever way of doing it.
So which planets exactly did Webb observe? You mentioned there were a few.
Right. So the main planetary system they focused on is called HR 8799.
HR 8799. Okay.
It's about 130 light years away from us.
That's pretty far.
Well, it is. It is.
Yeah.
But it's a system that astronomers have been studying for a while now.
Oh, really?
Yeah, because it's a relatively young system.
Oh, okay.
Only about 30 million years old, which is, astronomically speaking, very young.
Compared to our solar system, which is billions of years old.
Exactly. So it gives us this amazing opportunity to study planets that are still in their formative years.
Fascinating. And how many planets are there in this HR 8799 system?
It has at least 4 giant planets that we know of.
4?
Wow. Yeah. And they're all much larger than Jupiter.
So, truly massive, as we said.
Yes, truly massive. And they're orbiting their star at quite large distances.
How does their orbital structure compare to our own solar system?
Well, it's quite different.
Okay.
So the innermost planet in HR 8799 is called HR 8799e.
All right.
It orbits its star at a distance of about 1.5 billion miles, which is roughly between the orbits of Saturn and Neptune in our solar system.
Okay. So pretty far out there already.
Yes, it is. And then the outermost planet, which is called HR 8799b, it's much further out.
How much further?
Oh, it orbits at a distance of about 6.3 billion miles from its star.
Wow, that's like more than twice as far out as Neptune.
Exactly. So it's a much more spread out system than our own.
So we're talking about this really young system with these 4 huge planets orbiting at these vast distances, and Webb was able to directly image them.
Yes, and that's amazing in itself. But what's even more amazing is what they were able to learn from these images.
Okay, so what exactly did they find?
Well, they found evidence of carbon dioxide in the atmospheres of these planets.
Carbon dioxide, like the stuff we breathe out.
Exactly like that. Although I wouldn't recommend breathing on these planets. It's a bit different out there.
Well, try to resist that urge.
But yes, carbon dioxide.
Oh.
And this is a really significant discovery.
Why is that?
Well, carbon dioxide is a molecule made up of heavier elements, carbon and oxygen. And its presence tells us that these planets are not just made up of hydrogen and helium, which are the lightest elements.
Okay, so there's something more substantial to them.
Right. There's a significant amount of heavier elements present. And this is really important because it gives us clues about how these planets formed.
You mean like the whole process of how planets come to be in the first place?
Exactly. There are 2 main theories about how giant planets form.
Okay.
One is called core accretion.
Core accretion.
Yeah. and the other is called disk instability.
Disk instability. All right, break those down for us.
Okay, so core accretion is kind of like building a planet from the ground up.
Okay.
You start with tiny, solid particles in the disk of gas and dust that surrounds a young star.
And these particles are made of heavier elements.
Right, and these particles, they start to collide and stick together.
Over millions of years, I imagine.
Yeah, over very long periods of time, and gradually they build up a larger and larger core.
Okay.
And once this core gets massive enough,
It's got enough gravity.
exactly, it starts to pull in the surrounding gas, mostly hydrogen and helium,
Right.
and that's how you get a gas giant planet.
So it's a kind of snowball effect. It starts small and gradually accumulates more and more material.
That's a good way to put it. Now, disk instability is a bit different.
Right.
It's much more sudden and dramatic.
Okay.
In this case, it's not about building up a core.
It's like a rapid collapse.
Yeah, it's more like a portion of the disk itself becomes unstable.
Under its own gravity.
Right, and it collapses very quickly to form a planet.
Wow. That's quite a difference in timescale.
It is, it is.
So how does the carbon dioxide, how does that fit into all of this?
Well, the presence of carbon dioxide strongly suggests that these planets in HR 8799 formed through core accretion.
Okay, explain that connection for us.
You see, if a planet forms through disk instability, it should mostly be made up of the same material as the disk itself.
Which is mostly hydrogen and helium.
Right. But the fact that we see so much carbon dioxide means there must be a significant amount of heavier elements present.
And that points to a solid core.
Exactly. The core is where those heavier elements would have accumulated during core accretion.
So it's like a fingerprint, the carbon dioxide. It tells us how the planet was formed.
You got it. And this is really exciting for astronomers because it's the first time they've been able to directly observe evidence of core accretion in a planetary system other than our own.
So this is pretty groundbreaking stuff. And it really highlights the incredible capabilities of JWST, doesn't it?
It does. And it's not just about the direct imaging either.
Oh.
Webb can also study the atmospheres of these planets in even more detail using spectroscopy.
Spectroscopy. Remind us what that is again?
Right. So spectroscopy is a technique where you take the light from an object.
The planet, in this case.
Yes, the planet.
Yeah.
And you split it up into its different colors or wavelengths.
Like a rainbow.
Exactly like a rainbow.
Mm.
And by analyzing the pattern of these colors, you can figure out what the atmosphere is made of.
So it's like each element has its own unique fingerprint in the spectrum of light.
That's a great way to think about it.
So they can actually determine the composition of these distant atmospheres just by analyzing the light.
That's right. And they've already found evidence of other molecules besides carbon dioxide in the atmospheres of these HR 8799 planets.
Like what?
Well, they found water vapor, for example.
Wow, that's amazing.
It is. And they're hoping to find even more as they continue to study these planets.
It really makes you wonder, doesn't it? I mean, what else is out there?
It does. There's so much we still don't know about exoplanets.
Right.
But with JWST, we're finally getting the tools we need to really start exploring them in detail.
And not just exploring them, but also understanding how they formed, how common they are, and what that might tell us about our own place in the universe.
Exactly. It's all about getting a bigger picture of how planetary systems work, how they evolve, and what that means for the potential for life elsewhere in the cosmos.
Which brings us back to Earth, in a way.
Right.
By studying these distant systems, we can learn more about our own solar system and how it came to be.
Absolutely. We can start to see whether our solar system is unique or whether it's just one of many similar systems out there.
And maybe even get some clues about how life arose on our planet.
Exactly. It's all connected.
It really is an exciting time to be following astronomy.
It is. There are so many discoveries being made right now, and it's only going to accelerate in the years to come.
I can't wait to see what they find next.
Me neither.
Well, thanks for taking the time to break all of this down for us.
It's been my pleasure.
And to our listeners, thank you for joining us on The Deep Dive. We'll see you next time for another fascinating exploration of the universe and beyond.
See you then.
Bye, everybody.